Our notes today are also from section 10.5, and today we're going to introduce something called a combination, which I mentioned real quickly yesterday. I tried to be real clear when we were talking about permutations that we were arranging items and therefore order mattered. And I mentioned that tomorrow, just today, we'll talk about when order doesn't matter. So that's what we're going to look at here. Now, the top half of this page is really to try to get us to understand why the formula for combinations is what it is, why combinations calculates differently than permutations. So, focus more on like the why of what we're building right here. Okay, so we've got example 1, Ashlyn, Ben, Charlie, and Dylan were nominated for Ms. Cronky's MVP award. Only 2 of the students will be selected for a high five from Ms. Cronky. How exciting. Okay, list the sample space for selecting 2 students from the nominees. So, what are ways I could pick 2 of these 4 students? Like, name them. Well, like, how could I, of those 4, Ashlyn, Ben, Charlie, and Dylan, I could pick Ashlyn and Ben. I could do Ashlyn and Charlie. Ashlyn and Dylan. Ben and Ashlyn. Ben and Charlie. Ben and Dylan. Charlie Ashlyn. Charlie Ben. Charlie Dylan. Dylan Ashlyn. Dylan Charlie. Dylan Ben. Okay. So we were listing all these like different pairs and things. But when you think about what's happening in this scenario, if I pick, so let me answer, I guess, the question down below. If order mattered, how many ways would I be able to pick these students? 12. That's like our fundamental counting principle from yesterday. Or you could think about it like a permutation. Like I could choose any of the 4, Ashlyn, Ben, Charlie, Dylan. Once I choose Ashlyn, I only have 3 students left to choose from. So that'd be 4 times 3. That's also, I want to write that down here, sorry. 4 times 3. That's also from yesterday we talked about it's a permutation of 4 students chosen 2 at a time. Isn't that what 4 times 3 would be?
Right.
Okay. And so we get 12, and we listed them all out. And the reason I wanted to list them all out is, if you think about this scenario, the 2 people that I pick get a high five from me. So we've got Ashlyn and Dylan in class. So we'll say, if I pick Ashlyn and Dylan, or I pick Dylan and Ashlyn, either way, they get the high fives, right? So does Ashlyn really care whether I say her first or not in this scenario? No. Now, if there was a better prize, right, for one of the spots, then you would care which order you were chosen. But Ashlyn, Dylan, Ashlyn, in this scenario, because they're both getting the same thing, it really doesn't matter what order I choose. So if order doesn't matter, then how many ways would you count from that list? Would I be able to pick my 2 students? 6. How are you calculating 6 or seeing 6 up there?
Because I just added or subtracted all the ones that basically repeats.
Yeah, if you kind of go searching through this, you're going to find 2 where they're the same. Like, what do I have? An AC and a CA. I have an AB and a BA. I have a CB and a BC. I have a BD and a DB. And I have a CB and a DC. Right? So if order doesn't matter and I count up those different ways that I like boxed or underlined those things, there's really only 6 different ways to do things. Okay? So the question is, how do we put this into our permutation formula? If order doesn't matter, the answer is 6. Okay? And maybe you're thinking about, we're just taking the total numbers that there were and dividing it by 2. So we're saying it's a permutation of 4 items chosen 2 at a time divided by 2. Because like for every one group, if I switch them, it's the same thing. And what this 2 represents right here is the number of repeating sets. When I pick only 2 of some larger group, there will be 2 repeating sets. But if I pick a different set of numbers, let's say I change this example, so now I'm going to pick 3 students of the 4. And let's say I pick Ashlyn, Ben, and Charlie. Sorry, Dylan. Ashlyn, Ben, and Charlie. If those were going to be my 3 MVPs, how many ways could I rearrange those same 3 people? ACB, BCA, BAC, CAB, CBC, CBA. Yeah, there's 6. So if I pick 3, instead of having 3 repeating sets, I have 6 repeating sets. Okay. And where that 6 is coming from is 3 factorial. That's, if I'm picking 3, I have 3 ways to choose the first, 2 to choose the second, 1 to choose the third, and they could be in any order. But when order doesn't matter, all 6 of those things are the same thing, so I would only count that as one way for me to pick MVP, Ashlyn, Ben, and Charlie in any order. So if I were picking 4 from a larger group, okay, how many different repeating sets would there be for 4? Well, when there's 2, when I pick 2, there's 2 repeating sets. When I pick 3, there's 6 repeating sets. 24. Where are you getting 24 from? Thank you. Okay, it's coming from the factorial. Up here, when we're doing the 2, that's really 2 factorial, which is 2. So, down below, where we're talking about combinations, combinations are a selection of items in which order does not matter. And remember, this is really important. In permutations, it's an arrangement where order matters. I'm arranging things in a particular place. In combinations, I'm just selecting them, but it doesn't matter what order I choose them. Okay. So the order doesn't matter. My projector got bumped. I'll have to play that game where I go for that X. Am I close?
Up a little bit, right there.
Okay, so it's a selection of items in which order doesn't matter, and the combination, or the formula for combination, we're going to do a combination of n items taken r at a time, right? So this means r is like we're not choosing all of them, okay? And that's going to look like this, NCR. So when you guys were going into your formulas yesterday, or your PRB on your calculator, hopefully you noticed there was the NPR, the NCR, and then the factorial. Okay, so now we're going to start using our C. But this is what the formula looks like. N factorial over N minus R factorial, which that's really just permutations, right? Okay. With an R factorial in the denominator. And that R factorial is the number of repeating sets. So in that example we were working on before, if I only picked 2 students, there were 2 factorial repeating sets, which is just 2. So I divided by 2. if I were to pick 3 students at a time for my MVP award, instead of dividing by 2 or 3, I have to divide by 6 because there's 6 repeating sets. Okay, so that's included in the NCR programming of your calculator. So sometimes people will ask in math why we would ever learn all these things if our calculators just do it. Someone has to program your calculator. So they have to know how to do it, right? Okay, so we got to know the math behind it as well. You don't necessarily have to memorize these formulas because you'll be using your calculator function, but I just want to make sure everybody's clear, like they're really coming from the same thing. We're just dividing off repeating sets. Okay. So in that column, comparison, I think this time I have them in the right order. I do. Permutations on the left, combinations on the right. You can compare their formulas real fast. Okay. I modeled this formula for permutations yesterday. I think it was when we did the letters in the word thanks, and I did like 6 factorial over 6 minus 2 factorial, and all the 4 times 3 times 2 times 1 canceled and just gave us 6 times 5, which is what a permutation of 6 choose 2 would be. And then notice the only thing that's different with a combination is we got that extra r factorial, so we're dividing by the repeating sets. Okay, we don't want to include those. Huge, important. If there was one thing you would leave my room with today, and you should carry with you through the rest of the year to Algebra 3, to pre-calculus, in a permutation, order does matter, in a combination, order doesn't. So how do you decide between which formula to use? Does order matter? And then I got some keywords. I have to move this. Where is? Okay, tell me how close I am to that little X.
Right there.
Oh my gosh. Thanks. Now, these are keywords. I'll add some words to these lists, but you sometimes can use the keyword in a problem and it's actually the other thing. So you can't rely always on the keywords depending on who's writing or asking the question. You know, if like a non-mathematician person is asking the question, they may use a word from the other side that probably is not really exactly accurate in the scenario, but they're just saying it. Okay. So keywords for permutations. Arrangements. If you're asked about the number of permutations, that's a usual giveaway there. If they ask about places, you know, like we did that example yesterday where it's like how many ways could they come in first, second, and third place. If we're talking about positions, so you're going to be nominated as a president, a vice president, a treasurer. You know, those are different roles, or editor-in-chief and, you know, assistant editor-in-chief. Those are different. If you're talking about roles, like we're going out for the play, so I'd rather be Cinderella than her fairy godmother. Okay, so those are different things. Over with combination, some keywords. Combination. This is one that sometimes gets used over on this side by like other people. And so it doesn't always mean a combination, but usually it does. If you talk about committees, you know, if you just want to be on a committee, it really doesn't matter, okay, what order you get chosen for the committee. Choosing, selecting, teams are examples of combinations. So like, you know, spring tryouts are happening right now. At this point in time, you want to make the team. That's all you care about, right? Making the cut. It doesn't matter where you are on that list. Okay, so that would be a combination as long as you get chosen. As you get selected for the team, and then you get chosen for your positions on the team, or whatever, then order starts to matter, right? And like even for like dance teams, Order matters when they're setting up their dances, because Chloe's got to be in the front on the left in that spot. She can't just go dancing anywhere she wants in the gym, right? Okay. So sometimes in a team scenario, you can have it be a combination. I just want to make the team versus I want a specific role on the team. Okay. Okay. Here are some strategies for counting problems. This one, I would encourage you to go back to it and like kind of just do it in your own words or think about it as you're doing your homework assignment. The FCP, the Fundamental Counting Principle. I always think about that if I have to make lots of choices or have like different events. Like I'm flipping a coin and rolling a die, or I'm rolling 2 dice, or I have to pick shirts, shorts, and shoes for my outfit. Okay, those types of things. Also, passwords, usernames, license plates, PIN codes, all of those things are, automatically fundamental counting principle for the most part. Let's see, permutation. I think about permutations when order matters. When I'm picking R from a larger group. That would be out of N. Combination. Order doesn't matter. And this one is also, I'm going to, instead of pick, I like to write choose so that I keep the same letter as the combination. Choose R from a group. I often think, like, when do you really have to get into this whole business of, is it an NPR or an NCR? It's when you're reading in the scenario and you're going to pick or choose a few of a larger group. Down at the bottom, that larger looks pretty bad, I'm sorry. But if you're ever noticing that, like, oh, I have a whole bunch of students to pick from, but I'm only going to choose a couple of them, then you want to probably pick an NPR or an NCR. That's probably your easiest way to go about that. If you are picking all of something and you're arranging it, you could also use a factorial, right? The factorial is when we pick everything, order matters, and we go all the way down to 1. But we talked about that yesterday. You can also use the permutation. Okay, so we've got some examples on the back. I'm actually just going to give you and your pod mates some time. So I'll give you some time to kind of read through and come up with ideas. I'd write in pencil in case you and your pod mates come up with the wrong answer so that you can make the adjustments to your notes. So I'll check in with you probably at 2:05. We'll go through them, and then you'll have some time to work on your homework assignment. Okay. All right, get to work. Yeah, just do as many as you can. And if you and your group are super confused right now, let me know.
So that would be 4 feet. Or no, it would be 12 feet. That's 13, or 1,320.
it with what Matt's needed to do. And on your notes, I would definitely write your setup,
I got 220.
like the NPR, NCR, and the numbers that you put there. That way, when you look back tonight, you'll know what you checked.
What order doesn't matter, right?
So in order
So same order
Feel
doesn't matter.
confident.
So it's an order. It doesn't matter what order you pick. She's the first.
1,000. You only have 5 additional tickets.
Wait, how'd you get
Okay, wait, so that's what this, we're using the alphanumeric No, remember, okay. That's what I'm considering.
It's now at 0,
Here,
then fine.
it would be like that. Would this be 36? Yeah, so wouldn't it be different? Let's just put it simple. 46 or work with class device, that's different.
You guys are just like,
You know, the MCR.
well, if one's giving you a hard time, maybe go to the next one. I'd like you to have at least some time to look at them before I go over them.
For 4 or with 4, like that's more reasonable.
What's confused?
Oh, no, wait, okay, so NCR is one, we might put it backwards. NCR is one where it doesn't matter, right?
Would y'all get food served down there?
Here it
Yeah.
goes, right?
26.
What?
Oh, wait.
It's here, yeah, so that's, so that means that we're doing it, yeah.
Or it doesn't?
Well, what do I mean when I said open?
I mean, unless you're.
That's, the 26 is up to the, yeah, right?
Who's concentrating? Depends.
126.
Well, no.
Six straight.
That would just be hard.
It's like the,
Well, how many are there?
oh my gosh. Then I wouldn't do that. I would not.
Shut up, boy.
Wish you was.
So you said.
Live.
Yeah, you got to the fundamental accounting.
What is five?
There's 6.
Balance this.
But it doesn't matter which one goes first.
Okay, it is 2:05, so we'll go ahead and kind of come together. If you didn't get through all of the examples, that's fine. We'll hit them all. So we'll maybe take some more time later on so that everybody gets a chance to read through them. In example 2, a pizza shop offers 12 different toppings for the pizza. How many different 3-topping pizzas can be made? What'd you guys say? 220. How'd you get that?
12. NCR. 3.
Okay, a combination of 12 items, the 12 toppings chosen 3 at a time. You could say 12, choose 3 if you want. Okay, 12, choose 3. Does that make sense? So you chose a combination because order doesn't matter. You don't call Pizza Hut and say, hey, I want a sausage, black olive, and onion pizza. Make sure you put the black olives on first, or I'm sending it back. Right? Whatever order they put the stuff on, you take it. You wouldn't. I mean, it would be weird if they put the cheese on first, but you wouldn't have to specify that, right? Okay. And again, to kind of help you later on in the chapter, this is an example where I have 12 toppings to choose from, but I'm not picking all of them, so I'm going to try to choose NPR or NCR. Okay, so a lot of different answers for example 3, so we got to talk about this. You're creating an online username that is 4 characters long. It's made up of alphanumeric characters only. So what do I mean when I say alphanumeric?
Alphabet and number.
Letters or digits. So how many do you have to choose from?
36.
36. There's 36 alphanumeric characters. That's the letters plus the digits. Remember, I don't have to tell you there's 26 letters in the alphabet. You know that. Okay, I see some different versions out there. I see combinations of 36, choose 4. I see permutations of 36, choose 4. And I see 36 to the 4th. Are there any others that you want me to put up there? I think I got all the ones I saw. 36 times 35 times 34 times 33, and did you want to keep going? What's that?
We didn't use that method.
Oh, okay. I couldn't tell if you wanted me to write 36 factorial, but 36 times 35 times 34 times 33 would be this, right? Okay. Okay, now which one of those is the actual right answer?
36, choose 4.
Okay, so you might be thinking about, like, when you're picking your username, the order of the letter, like the order that you pick those letters wouldn't, or letters or numbers wouldn't matter. But when you go to a website and you type in your username, does it matter what order you type the letters or numbers in your username? Yes. So I would say order matters for usernames, passwords, PIN codes. You can't just put them in any order you want.
Yeah.
Okay. Now, permutation, 36 items chosen 4 at a time, or 36 to the 4th.
You could do the same.
Are you allowed to have the same number or letter in your username?
Yes.
Most likely. So we don't want to choose 36, pick 4. That means 36 times 35 times 34 times 33. We want to say, I have 36 things I could choose for my first part of my username, 36 things to choose for my second part of my username, for the third, and for the fourth. So when you're thinking about that one, remember what I said, for FCP on the front, usernames, passwords, license plates, PIN codes, right? If you're choosing letters and numbers to build a word or a student ID or something, use fundamental counting principle. Okay. I should have updated this to something cooler than Taylor Swift, huh? I usually try to update some with the times. Yesterday, my time was a buzz that the Jonas Brothers were getting back together, so I could put that up there.
Their new song is really
the Jonas Brothers used to be there, but then they went away. So then I had to put someone else. Who should I add there for next year? Do you think? A Drake concert? You're going to a Drake concert? Okay, Cardi B concert. Yeah, I could do that. Okay, 9 of your friends want to go to the Taylor Swift concert. You only have 5 additional tickets. How many different groups of friends can be chosen? How are we getting our answers? More than the number answer, I care about the how, right? So tell me how you're getting your answers.
Wouldn't order not matter?
Order wouldn't matter. So it's going to be a combination of choose 5. I go pick 5 of my friends. Now, in reality, if I have, 5 tickets and I've got 9 friends who really want to go with me to see Taylor Swift, and I choose Taylor before I choose Hannah, Hannah's feelings might be a little hurt. But then when Hannah realizes she actually gets to go to the concert and I'm leaving Kaylee at home, then Hannah's at least happy she's going, right? So then order doesn't really matter, okay? Okay, what's the next one?
14 students are running for class president.
Yeah, class president, vice president. How many different ways can they be elected to these positions? What'd you guys use? FCP, permutation, combination? Sorry, what? Permutation. Why a permutation?
Because it matters.
It matters. Wouldn't you rather be president than vice president? You like to boss people around? Me too. Okay, permutation of 14 people picked 2 at a time. So that'd be just like 14 times 13. You wouldn't have to write that out as a permutation. You could say like there's 14 ways to get the president, and then once we choose the president, there's only 13 choices left. Okay, all right, moving right along. 12 students are running for 4 open spots on the student council. How many different ways can they be chosen for the council? Fundamental counting principle, permutation, combination? Combination. Does it matter what order they get chosen? No, you just want to be on student council. How many people do we have to choose from? 12, and we are picking 4. All of these where I'm doing NPR or NCR, I can tell that I'm going to decide between those 2 forms because I have a large group to choose from, but I'm only picking a few things, right? Okay, so I have my total on the left, and I've got how many I'm picking on the right. And then we should have, is this the last one? So it switches over to probability now. Mr. Arnold has selected 13 pottery projects, including Darby's and Emily's, to be placed in the display case in the front of the Titan Theater. There's room for 2 projects in the middle of the middle row of the case. What's the probability that Darby's and Emily's project are the 2 placed in the middle row? So now we're asking the question of probability. There's lots of ways that you can do this one. Just like yesterday, we did one last problem, and there was lots of ways to do it. So give me some ideas. You did a permutation of 13 items chosen 2 at a time. And why were you doing a permutation?
Because
Because the only spots are in the middle row, so it has to be.
Well, the only spots are in the middle row, yeah.
The order has to be like those 2.
Yeah, wouldn't it be combination?
Because it doesn't really matter which slide.
Okay, so then we're questioning, is it a combination? So I think the answer to that question is how this would be our numerator or our denominator for probability. It would be our denominator. I think it's how you see the numerator that decides what answer you put here. So what do we want to say for our numerator? There's 13 ways to get Darby and Emily's in the middle row. Darby? there's two spots, right? And it's either going to be Emily, Darby, Darby, Emily. For this to be the thing that we want, right? The there in the middle. And so if you do that, then we're saying order doesn't matter. If order does matter, how many ways? 2. You could do Emily, Darby, or you could do Darby, Emily. Okay, but you should get the same answer. Okay. We're going to have some time to work on our homework assignment, which is a worksheet. This time, Taylin can pass it out since she's so speedy.
I have to go slow, folks. Hurry up.
Izzy, I don't really like your attitude. Yeah, I really don't like your attitude.